So solve a triangle means to find all missing sides and angles. And all it is a combination of the two types of problems we learned about last time: solving missing sides, solving for missing angles. We're just doing it in one single triangle rather than in a couple. So here's an example. If we knew the hypotenuse was 12, and we knew, let's say that this is a 51 degree angle, and you're also going to see letters around here. The right angle is always going to be C, and then you're going to have an A and a B. That's 12. The hypotenuse is 12. The directions here are to solve the triangle. So first we got to figure out what's missing, and we got to find what's missing. Find the value of what's missing. Triangles have three sides, three angles. We have angle A, we have angle B, and we have angle C. These are capital letters. Capital letters mean angle measures. And then we have side A, we have side B, and we have side C. The lowercase letters mean side lengths. We got to find the values of all of these. What do we already know?
A is 51, big A is 51.
A is 51 degrees. C is 90 degrees. And we can actually find angle B without having to use trigonometry, without having to use sine, cosine, or tangent. This one's going to be pretty easy for angle B.
180,
Exactly. You add the two. This was from last unit. If we have two angles already and we're just trying to find a third angle, you add the two, subtract from 180. So the missing angle was pretty easy to find. It was 39 degrees. B equals 39 degrees. So we got all the angle measures now. Let's focus on the side lengths. You got to be careful on what we call A, B, and C. The side lengths are opposite the corner. So if this is angle C, then what do we call this? That's side C. So we know the little c is 12. What we're missing are side A and side B. Now we can't find these using Pythagorean theorem. Pythagorean theorem only works if we know two sides and we're trying to find a missing third side. We're missing two sides. So we have to use trigonometry. Just choose one. For example, if we want to try to solve for side A, choose one of the angles that you know. For example, if I want to solve for side A and I want to reference this angle right there. In reference to this angle 39 degrees, what side is side A? Opposite, adjacent, or hypotenuse? That's the adjacent side. And use the side that we already know. The hypotenuse is 12. What does that sound like? Adjacent and hypotenuse. Sounds like cosine. So to find side A, you could if you wanted. If we used 51 though, then what would that be? No, if we wanted to reference 51 degrees instead of 39, then what would side A be? That would be opposite over hypotenuse. So there you could use sine. So either one would have worked, but let's choose 39 for right now. Side A then would be cosine of 39 equals side A over 12. Cosine of 39 equals A over 12. And now we just have a problem that we solved on the quiz. How do we solve for A? Multiply 12 on both sides. Exactly. 12 times cosine of 39 is what A equals. 12 times cosine of 39, 9.3. So A equals 9.3. Now we do a similar thing for side B. And we don't have to use 39 degrees. We could use the 51 degrees if you wanted. But depending on the angle you choose to use, that determines whether you're going to use sine or whether you're going to use cosine or whether you're going to use tangent. Exactly. Now if we wanted to use the 51 degrees to solve for B, we could use cosine again. Because side B is adjacent to angle 51. So side B could be found using the cosine of 51 equals B over 12. That's a B, not a 6. That's B over 12. Now we do the exact same thing. Multiply by 12 on both sides.
What should then equal 10.6?
12 times the cosine of 51 is 7.5. Let's call it 7.6. Okay, there's a theorem that we haven't learned about yet. I don't know if we'll ever learn it in secondary 2. It might be a secondary 3 thing. But the sides of triangles are in relation to the sides of the angle. Isn't this the smallest angle right here? So the side opposite that has to be the smallest side. Okay? Right now 90 degrees is the largest angle, so the side opposite that is the largest side. And then 51 degrees is the medium-sized angle, I guess you could call it. So side A has to be the one that's the middle length. So that our side lengths make sense. This one was 7.6 for side B. Side A was 9.3. Solve the triangle. We found all the missing sides. We found the missing angle. Okay. Let's think about another one here. That's what it means to solve a triangle. Find all the missing sides, all the missing angles. Example 2. I know. So we have C right there. Let's call this one down here A. Let's call this one B. Let's say we know that this one is 7. That side there is 7. And we know that this one is 22 degrees.
So we get C is 98 to 60, and A is 22.
Yeah. If we list the angles, A, we have angle B, and we have angle C. We know angle C is 90. It's always going to be 90. We know angle A is 22 degrees. So angle B has got to be 68 degrees. That was the missing one.
Little A is 7, and
Little a is 7. We know that. We don't know side B, nor do we know side C. Well, which one do we solve for first? Want to solve for C? C is the hypotenuse. So choose one of the angles. It doesn't really matter which one, 22 degrees or 68 degrees. It truly doesn't matter. 22? So if we're choosing 22, then in relation to 22, C is the hypotenuse and 7 is the opposite. What does that sound like? Opposite hypotenuse is the sine. So for C, we could say that the sine of 22 equals opposite over 7 over C. Opposite over hypotenuse.
multiplied by what?
We're in times by C on both sides, because that gets rid of the fraction at least. So now we have C times the sine of 22 equals 7. Not yet. Divide sine of 22 on both sides. 7 over the sine of 22. That you can type into your calculator. 7 divided by sine of 22. 18.7. Do we expect side B to be smaller or larger than side C? Why smaller? And because C is the hypotenuse. C has to be the largest side. Now, let me give you some options for side B, which is this little guy right here. We could kind of repeat the process and use cosine or sine or tangent. Can anybody think of another way to do this without using sine, cosine, or tangent at all? Don't we now know two sides of a triangle? If we know two sides already, how can we find the remaining third side? Exactly. We don't have to do trigonometry anymore. Now that we know two sides, we could, if we wanted to, just use Pythagorean theorem. Okay. We could do 7 squared plus b squared equals 18.7 squared. 49 plus b squared equals 18.6. I'm going to use the exact form. That's why mine says answer. That's this answer here. If you square that, you get 349.17. If you subtract 49, you get 300.17. And then how do we get b? Square root. So now you can square root that previous answer. You get about 17.3. We found that using Pythagorean theorem. You didn't have to use trigonometry. We found all the missing sides. We found the missing angle. Here's one that's slightly different. Here, all I'm going to tell you is that C is a right angle. That's it. I'm not going to tell you the other two angles, but I am going to tell you that the hypotenuse is 25 and this side is 7. So we have more angles to solve for. What the? That side is 7. So all we have to solve for is one remaining side. But there's two angles that we're missing. What's that? Yeah, we don't know angle A. We don't know angle B. We know angle C is 90. It's always going to be 90.
Wouldn't it be like 45 each? We don't know.
Well, we know the bottom length is 24 because of the triples.
Yeah. Side A, side B, and side C. We know side C is 25. And we know that B is 7. If we already know two sides of a right triangle, how can we find the remaining third side? Pythagorean theorem. A squared. It is. If you recognize these two numbers, they're part of the triples. So, if you've memorized that, that's great. it turns out to be 24. If you haven't memorized those, you're going to have to do the whole theorem. A squared plus 7 squared equals 25 squared. That turns into a squared plus 49 equals 625. If you subtract 625 minus 49, you get 576. And then you square root 576, and you get 24 exactly. So the missing side was 24. How did we find missing angles on the quiz?
Isn't that right there anyway? Factoring triples?
Yeah, 7, 24, 25 is a triple. But now we got to find angles. Let's choose one. Let's say we want to find the measure of angle A. So imagine that there's a theta symbol right there, and we don't know the measure of it.
If
Okay?
sides are double or half the triple, that still works, right?
Correct. So let's say we want to solve where theta is now. We're trying to solve for angle A.
Yeah.
We can use any trig function now because we have all three sides. So choose whatever trig function you want. For example, what if for angle A I said, okay, I'm going to use the sine of theta. Now if I use the sine of theta, you've got to choose the correct sides for sine. If theta is here, what are the correct sides for the sine? What do you think, Reese? Huh? Put that away. Angle theta is right here. And I'm talking about the sine of theta. So what two sides do I need for the sine of theta? Okay. But now I'm interested in what theta itself equals. I don't want the sine to be there. Somehow we got to get rid of that sine.
You just drew a heart around it.
That was weird, huh? I love that angle sine. Or that angle theta. How do we get rid of sine? Inverse. Inverse sine, like we learned on last time's assignment, like was on the quiz. If you're trying to find an angle measure to get rid of a trig function, use inverse. So theta where it is now is equal to the inverse sine.
How in the world do you have that because of what you used to?
It's going to be the second and then the sign. I'll show you.
Second and then sine.
Okay.
And then 24 25ths means it's 73.7 degrees. 73.7 degrees.
Angle A, that's where I put theta. But we don't have to use trigonometry anymore, because now we know two angles of a triangle. How do you find the third angle of a missing? How do you find the third angle if you already know two?
That's to find a missing side. You add the two angles together, subtract from 180. So if you have 90 plus 73.7, and then you subtract that from 180, you get 16.3. That's what it means to solve triangles. That's all it is today.